As the world's largest energy producer and consumer, China's resources and energy are concentrated in the west and north area, while electricity consumption is concentrated in the southeast coast. The special resource endowment makes it necessary for China to establish long-distance and cross-regional dispatching super energy channels. The Ultra HVDC power transmission highways, which can send huge amounts of electricity to thousands of miles away, which is the key technology to measure the level of a country's power equipment. Nowadays, China has put into operation more than 25 Ultra HVDC transmission lines, with a total transmission distance of more than 33,000 kilometers, which constitutes the world's largest power grid scale. However, with the rapid development of renewable energy, China has become the largest country in hydropower, wind power, and PV generation, and the proportion of renewable energy continues to increase. In order to integrate these fluctuating, intermittent, and clean electrical energy into the grid, it is imperative to upgrade the power transmission technology in order to avoid the upheaval along the way. This requires more advanced power transmission equipment, and 6 heavy-duty trucks departed from Xi'an to Lubei, Guangxi, loaded with the most advanced power transmission equipment. The precise equipment will be violently shaken, and the speed of the vehicle must be strictly controlled within 70 kilometers per hour. Then, 1,700-kilometer journey takes a full 24 hours. The equipment successfully arrived at Lubei Converter Station in Guangxi. These devices use the flexible DC transmission technology with the highest controllability in the world. And then, the workers will carefully assemble these precision equipment in the hull of more than 5,000 square meters to build a flexible DC converter valve with the highest voltage level in the world. When the converter valve operates in the future, the voltage is greater than 800 kilovolts. A little burr during the installation process, or even a little dust and iron fillings on the left surface may cause a short circuit or an unimaginable discharge during charging. Therefore, engineers cannot use power tools and must use manual installation. Such complex construction takes 2 months to complete, even if the experienced engineers work together. The converter value is the bridge between DC and AC. The new generation of flexible DC converter valve has a faster power regulation speed. It is possible to quickly compensate for the fluctuating pure energy charge and power, turning the aggressive and unruly currents into softness, making it possible to connect pure energy to the grid. At the same time, it can shorten the grid troubleshooting time to less than 100 milliseconds, just like installing a dam with an intelligent brain in a river that is flooded with water. Precisely controls the direction and size of the power tide to support safe and stable operation of the grid. And the secret to achieving this function is hidden here. In the 100,000 grade cleanliness workroom, workers are crimping together IGBT, driver board card water-soluble board, etc., to combine into a complex flexible straight module. This is the core of the flexible DC converter valve, and the crimping force must be strictly controlled. The fully digital torque wrench senses the force of the workers in real time and displays the value on the monitoring screen to ensure the bolt torque accuracy of more than 3,000 submodules in the whole converter value is the same. Another core component is the control card, which is the brain of the flexible DC converter valve. This seemingly ordinary card has tens of thousands of electronic devices, each with an independent transmission line, capable of extremely high-frequency transmission of over 1 billion hertz. Such a massive and fast data processing capability is the equivalent to the entire valve control system having uploaded data 8,000 times in the blink of a human eye in 0.2 seconds. The technology is currently a global power giant and is seizing the high point of energy applications technology. There are only 3 countries in the world that can manufacture it. It took 2 months, and Tbea extra HVDC high valve hull with 2,592 modules totaling 216 valve sections was all installed. This is the world's first ultra-high volt multi-terminal flexible DC converter station and the world's highest voltage level and largest transmission capacity multi-terminal hybrid DC project. Before they are officially put into operation, they must also undergo an energization test. Energization is the key moment to test whether the entire system is built and qualified. The crew is all in position and ready to execute now. The test begins and the main gate knife starts to extend forward, which will make full contact with the static contact bar and engage tightly. In this process, any abnormality in the equipment will lead to the termination of the closing action. Once the power is successfully energized, China will be able to raise the ultra-high DC voltage level from plus 350 kilovolts in the past to plus 800 kilovolts, and the power delivery capacity from 1 million kilowatts to 5 million kilowatt level, with the main gate knife fully opened and 1,210 amps of current passing through instantly to complete the closing. The new HVDC converter valve, which is ready for operation, will be used in a brand new flexible DC transmission line, the Kun Liu Long DC project, which can send 33 billion kilowatts an hour of electricity generated by the world's 7th largest hydropower plant, the Wudongdae Hydroponic Station, across the Guangxi to Guangdong, about 1,452 kilometers. Flexible DC transmission technology, which enables faster and more flexible grid regulation, is considered a key technology to cope with the future large-scale grid integration of renewable energy. Upgraded technology and equipment have taken China's power transmission capabilities to the forefront of the world once again, and the human vision of electrical energy does not stop here.